Okay, welcome back everyone. So we have a competitive programming problem that is definitely not just a math problem in disguise. I think I already know what's going to happen, but you're given a two regular undirected loopless graph, and then people take turns doing an operation where they can delete any connected subgraph, and whoever can't make a move loses. So for those of you that don't know, let me tell you something very interesting about two regular undirected simple graphs. They're literally collections of cycles. Like that's it. So you have a bunch of cycles. Thank you, Raven Monofizz, for the follow. And you have the cycles, and you can like kill parts of the cycles. So, yeah, okay. This is gonna be nim. Basically, you only care about the number of vertices. The graph structure is basically completely a red herring, and there's a game called nim, which is equivalent to this, which is you have some piles of stones and you take them out. Okay, so we're just gonna like run this over, all right? And n is 2 times 10 to the 5th, so I think we can just run it over. So NLR, let's see. L is the, what is L? Actually, it's not quite. Okay, wait. I'm not gonna spoke. L is the. So there's an upper and lower bound on the number of things I can erase. Okay, that changes things. Frick. I was just like, oh, this is just new. It's like, oh, there's 2 more parameters. Shh. So in the case where L is 1 and R is like n or some other large thing, it is actually just nim. So then the question is like, does anything change if, like for example, I'm not allowed to take just one vertex away? Wait, I actually don't know how to do this anymore. I was just looking at this, I was like, lol, and then... Okay, okay, now I have to actually think. So it is equivalent to some shape of nim. So each cycle is a subgame where you have a pile of stones and you can take between L and R of the stones. And Shiba. Maximum excluded. So I don't actually know what that means. Oh, max of... No, I know that you're supposed to compute the number for each cycle. I just don't know how to compute the number. I mean... The tax is DP. I mean... Oh, am I... I should be logged in so that I hide the tags, honestly. I forgot to do that earlier. Yeah, I do have tags turned off. I just forgot to log in. Because I'm logged in on a different browser. Let me. Yeah. I mean, lines of length k and cycles of length k, I think, are exactly the same. Like, you don't care at all. Um, okay, so we're gonna start by computing some numbers. All right, compute number. And so for everything that's less than L, it's like L, and then max is max excluded. Yeah. Okay. For I in range n, numbers.append. So you take the last wait, hang on, how does this work? So in nim, it's like you have you have game states called 0, 1, 2, etc. And then it's you just keep adding 1. So in this modified variant, so I have a bunch of games called 0, and then it's like 1 plus the max of the last. Minus L minus R. That can't be correct. No, wait, I'm so confused. Oh, shit, how does this go? Lines are cycles. Oh! Oh, you can cut the... You can split the pile. Oh, Shiba. Shiba. Oh, crap. Okay, you're right. It's different for cycles and... Shit. Yeah, number addition is exclusive or okay. Oh god. Wait, this feels like a lot of math. I'm okay. I'm a little surprised. Okay, how big is 2 times 10 to the 5th? Oh, this is bad. I actually can't do n squared. Crap. Oh no. Oh no. Yeah, 10 to the 5th is too big. That's the problem. So SPRAGUE Grundy guarantees that the game should be equivalent to some number state. I don't know. So SPRAGUE Grundy is a guarantee. Everything's equivalent to number state. It feels like I should be trying to do some math to like get a pattern. Yeah, but I want to solve. Okay. Yeah, I figure there's probably some. Okay. Yeah, I need a completely number for a line. That's okay. I can. Okay, fine. We will put our math morals aside for a moment and then just brute. I can't believe I'm doing this. Okay, so if you have a pile of so the number for when you have a line, the number isn't even like. Okay, well, let's start with 0. So, okay, well, I can't believe I have to do this. Oh my god. LR. Okay, so we pick a place that we're going to cut at, which is an index between 0 and the length of the S. Okay, so if I have s equals 0, let's just start at 2. Okay, at s equals 2, but see, the pattern is in terms of n, l, and r. That's what makes this so obnoxious. Like, it's just, there's so many. So, states equals set. Actually, no, sorry, this isn't even correct. Oh lord. Okay, so I need to pick an index to cut, which is anywhere from 1 to, so like 0 to S. And then I need to pick a length to cut, which is anywhere from L to R plus 1. And then A and B are this is so stupid. Can I just do the math instead of writing the code to do it for me? Like, I probably need a lot of test cases anyways, though. You know what? You know, I'm gonna... We're actually just gonna use the iPad. I'd actually rather do it by hand than write the code, because the index crap seems super annoying. We interrupt our regularly scheduled programming to bring you, No, the math is fine, because it's you can manually compute the max, right? Well, maybe I'll eat those words momentarily. But... the real problem might be that my iPad is not reacting. Come on. Shiba. Okay, a line showed up. That's what I need. Let's do like R equals... What the frick? Okay, so numbers. 0 is 0, 1 is 0, you can't move, 2 is 0, 3 is 1, okay, 4 you just go to 1, 5 you can go to 1. Okay, so 6 is the first interesting one. You can go to like 0 XOR 3, 1 XOR 2, 2 XOR 1, 3 XOR 0, or really actually a lot of things. Actually, it's not actually that hard to describe. I'm like these things, and it's like, what is the maximum excluded value that it's like, what's so. Or sorry, max. Max is minimal excluded. So, okay. Okay, so I see a 2 here. This is 1. 3. Sorry, wait, no. These aren't the numbers. These are the sub thingies. You know, I probably shouldn't have picked 5. I think 5 might be too small. Let me bump this up to like 10, so it doesn't matter for a while, and then we can see what happens. Wait, when am I smoking? So 6 is like 0 or 3. So this is the first time it gets to 2. Right. Wait, wait, is 5 better? Okay, I'll do 5 if you think that's better. I just feel like I'm running into this issue where like 3 times 2 is really close to, I don't know, okay. Okay, but 6 is definitely 2, right? Because from 6 you can get to... I hate you. Okay, we're just gonna do 5. 7, I can go to like... So like the total number of stones left over after an operation is going to be either like, it's like between like, so 0, 0, 0, 0, 0 to 1, 0 to 1, and then here's the first time it's like 0 to, or like 1 to 2, 2 to, so after a while it starts, it's like 1 to 3, 2 to 4, and so on. So you have like a total left, and then you can take the total left and split the quote-unquote total remaining and split it however you want and try to XOR those two numbers. And the question is like, how small can you get? Or like, yeah. So the 2 to 4 range, like if I have... So 2 to 4 should be a 6, because all the numbers below this are like smaller than 2. So it's kind of like... Yeah, you can't get you can't XOR two numbers in from 0 and 1 to get a number that's at least 2. But 3 to 5, so you can get 0, you can get 1. So this should be 2. And then 4 to 6 is the first time that I, like a 2 appears at all. But I think the... Okay, so I think what I want to do is I want to cache, like, values of A exclusive or B. Like, if I take two things, for example, if I have a pile of 4 stones and I want to split it, what are the numbers I can get out of that? So up until here, it's like 0, 0, 0. If you have a 3 and you want to split it, I guess you can get 0 to 1. If you want a 4, you want to split it, you get 0, 1, 0 to 1. And if you have a pile of 6, it's still 0 to 1. You cannot get... Yeah, 7... Yeah, the first time you can get something that is bigger than... It's like 0... Can you get... Sorry, no, this is 0 to 2. 0 to 2, 0 to 2. Okay, so I think R actually doesn't do anything. Because the fact that you can take the path and like chop it into two things and XOR them together, I think that essentially just means that, you know, it XORs to whatever the heck it wants. So I think the number is literally like floor n over L. Yeah, I think R doesn't matter because like the upper cap is irrelevant given that you can just cut the thing into, like, even if L equals R, is that a case that's allowed? It's not allowed in the problem statement, but even if L equals R, I don't think it changes anything. Because you can cut. Yeah. So the claim is by induction, like it's the floor as the number, and then all I need to show is that if I have, yeah. Like for example, if I have a pile, if I can go anywhere from 100, if I have like 100 stones, I can split it into two piles such that the floors XOR to any number that's less than or equal to 33. For example. Is that a true fact? No, that's not quite true. There's a parity issue. But if L is strictly less than R, I don't think there's a parity issue. Evan, you don't need to prove things. I am running a math stream here, okay? I want to prove that the algorithm works. Do I need to remind you the name of the stream? Okay, I agree that on CodeForces you don't need to prove things, but I am a completionist, okay? Yeah, I think if you allow deducting by 1, you don't have a parity issue. So I think this should just work. Yeah, if you have access to at least 2 choices, then you shouldn't have a parity issue. And then you can like... It should be fine, right? Science and technology, thunk. There is no ping on Discord? Did I not ping on Discord? Shit. Shiba. No, I pinged on... Oh, I pinged on the public one. I might not have pinged in Otis. Okay, sorry, my bad. What did I get on 12B? 138, yeah. Both due to reading comprehension issues, so I can't really complain. Okay, cool. So that does it for a line, and then for a cycle, it's like you... I mean, you know the numbers, right? Like you can actually just XOR them. Wait, actually, how does that work? Wait, actually, how does that work? So, the SPRAGUE assertment is that it's the minimum excluded value among all the states that you can reach. Is that true? That's true, right? There was a ping in the public venhance server. I think I forgot to ping Otis itself. So sorry, my bad. Yeah, no, I think I forgot about the Otis. Maybe, I don't know. I don't know anymore. Okay, anyways, so it's like you take the floor of over the L's of the... Okay, so R matters for the top. I guess that's what's going on. Like... Wait, seriously? Okay, anyways, it doesn't matter. Alright, we're gonna just implement this now. I think we know what's going on. Okay, so define number for line of length s. It's like return int s. Well, actually, this is long division. And define number for cycle. So, for a cycle of length s, at least 3, we if s is at least L. So if f is strictly less than L, then that's an interesting case. Or if s is greater than or equal to L, then there's no way to reach 0. So the number for the cycle is just 0. If s is strictly less than L, then 0 is included. The largest number that is included is s minus L. Wait, hang on. Okay, if L is less than S is less than or equal to R. So if it's less than or equal to R, you can get to everything starting from S minus L, which is 0, to S to like just 0. Hang on. Wait. Oh, the signs are so confusing. Okay, so S minus L is just the biggest number, and then that's it. So then we number for lines, and then we increment by 1. And else, in the case where S is much larger than R, the largest... Wait, I'm very confused. I think I flipped the case. So if I have like 100 stones and L's are 3, 5, then I can get to like anywhere from 95 to 97. Wait, so if S is greater than R, if S is greater than R, that's the only case that I can't get to 0 necessarily. So I think this is like return... Hang on, no. Hang on. Okay. If S is greater than R plus L, return 0. And if S is greater than R, then you can reach a continuous range from 0 to whatever you want. To the max, which is that. And then else, if S is at least L, I mean, it's still the same thing. You can reach anything. So this case is actually the same, I think. As long as I can get to at least L. Yeah. And if S is less than or equal to L, if S is strictly less than L, then there's no moves to be made at all. Okay, and then, alright, so... That's fine. Then I need to actually compute the number of connected components, which is the most annoying thing ever. Does anyone know how to do this offhand? Because I really don't want to worry about it. How do you compute the number of connected components? Or like characterize connected components? to DSU or any flood fill. I don't want to implement flood fill. It's all cycle, so it's not that bad. I mean, yeah, but it still sounds super annoying. This is not against the rules, right? That I can just copy snippets for standard algorithms like this. Wait. Wait, I'm so... This is... Sets are O1 in Python. We'll just use this one, because this one looks like it's... Okay, let's get the graph. For a line, insist.stand-in.readlines. EW equals line.split in chunk graph v dot add w graph w dot add v. You know, this feels awkward to me because it's like graph is, you know, treated as a global variable. It feels like I'm actually going to change this. This bothers me too much. It's having both a global and global rather than a map of sets. I believe you. Oh, I see. Will I time out if I do it this way though? Because it's only a 10,000. Yeah, okay, fine. Final number for component in oh, I see. This is shorter. Number, is it? How do I XOR in Python? Is it? Yeah, XOR. Equals, get number number for cycle, length component. If final number equals 0. Okay, what's the final output format? Print either Bob or Alice. Okay, let's see if that works. Oh god. Shoot! I overwrote. Ah. I overwrote the wrong thing. Okay, let's see if this works. This took way longer than I wanted it to. Crashed! Okay, great. Alright, what did I screw up? What? Oh, fuck. Shiba! Did I screw up the input format? Oh, what the heck? I don't know how that happened. Okay, cool. Seems to be kind of working. Let's see if this goes. Did I miss an edge case? I probably missed some edge case. We'll find out soon. We're just gonna submit this and pray, and on the off chance that it gets accepted, I can stop thinking about this. Submit! It better pass test 1. Test 3. Okay. Okay. Test 5, 6, 12. Alright. 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 How many? Okay. We did it! Okay. That's not good. Oh my god. That took way longer than I thought it was gonna. Because I didn't read the part about L and R, and I was like, wait, this is literally nim, but it's only isomorphic to nim, but you have to work at the isomorphism. Frick. Alright, cool, we did it. Well, I hope you learned something new today. I actually did not know the theorem was that strong, that it was actually, like, all games are... I didn't actually know this theorem, that it's like, not only all games are isomorphic to nim if they satisfy, impartial and normal play. I actually didn't know that theorem, so that's good to know. And not only that, but the number is actually exactly the maximum excluded value. True and partial games are quite strongly solved. Yeah, I mean, yes, because this theorem it tells you exactly what it is. But yeah, I actually didn't know this, so learned something new today. And also, CodeForces. This is why I did Math Olympiad. Okay, alright, moving on.